When you're multiplying rational expressions, the first thing you want to do is factor everything you can. Because once you factor, you can see how these different terms are made up of. Different chunks, different pieces, and if we find matching pieces on top and bottom of these rationals, these fractions, we're able to cancel terms out, make our answers a lot more simplified. So that's what we're going to focus on today. So starting with our first example, let's say we have 5x over 8 times 9 over 5x. So we have two rationals, two expressions, well, two fractions, and we're going to multiply it together. Now on the top, I could do 5x times 9 and make a 45x, because that's how you do it for fractions. You just multiply across the top and across the bottom. On the bottom, 5x times 8 gives me a 40x. And now we can simplify this. The x's cancel, and top and bottom are both divisible by 5, so we get a 45 divided by 5 is 9, and 40 divided by 5 is 8. And that's my fully simplified answer. But maybe, was there an easier way that we could have done that in the beginning? So let's take a look at the same problem. In the end, if I see the same chunk on top and bottom, I'm able to cancel them out. So this works for multiplying. I have a 5x and a 5x. Those cancel. And when I multiply all this together, that's a 1 and that's a 1. 9 over 8 is my answer, as I had gotten before. So if we have the similar things on top and bottom, we can cancel those out. So let's say we have a 6y plus 2 over 20 times 4y over 3y plus 6. So now we have some binomials throughout here. So first thing I want to do is actually factor this time. So on top, maybe I could multiply that out and multiply, but that's a lot of work. Let's see if stuff will factor out. So I can't factor this top left corner, so I'm going to leave that alone. Can't do anything here to the 20, the 4y, can't do anything, but on the bottom here, this one, I can factor out a 3, leaving me with 3 times y plus 2. And if I start looking at this, now stuff can cancel, because I have a y plus 2 chunk on bottom and a y plus 2 chunk on top. Those cancel. And if I keep looking, now I'm going to see if I can simplify some stuff. So 6 over 20, those numbers do reduce as well, both divided by 2. So 6 divided by 2 is a 3, divide this by 2 is a 10, and the more I look at this, the more it can cancel. Because now, on top I have a 3, on bottom I have this 3, and any time you want, you can start multiplying this, but eventually there may be some more simplifying, so possibly the more that you can do now, the less you have to do later. It does make things look a little bit sloppier, but all I've got left now is a 4y on top, and then this 10. So maybe I'm kind of fed up right now, and I want to sum up what I have, 4y over 10, because there's nothing else left. But those do simplify a little bit more, both top and bottom by 2. So you get a 2y over 5 as a final simplified answer. Again, something I could have done up here by making this a 5 and this a 2. As long as we're working together, doing the same thing on top and bottom, looking for things that fully cancel and then things that maybe simplify. Let's take a look at a bit more complicated one. Let's say we have 7m squared, m plus 4. Down here an m minus 3 and an m plus 4 multiplied by an m minus 3 and an m squared plus 14m plus 48. Now, really, there's no wrong way to do these, except for don't multiply stuff out if you don't have to. Like here, I would not multiply this out. That just makes things more complicated. This is already parenthesis form. It's already factored. Leave it how it is. We want to factor stuff. So if I look through the pieces, this top left can't factor anymore. This can't factor. That can't factor. The only thing that can really factor anymore would be this piece here. And it's a 3-piece. So that 3-piece, let's go ahead and use X factor to figure this out. right? So what we've got here on top is a 48, on bottom a 14. So I'm looking for two numbers that multiply to give me 48 and add to give me 14. Those numbers are 8, positive 8, and positive 6. So now I can rewrite that in parentheses form. I can rewrite that into parentheses form. And actually, I'm going to write everything back out again. M minus 3, m plus 4, m minus 3. And now I'm going to translate this part into a factored form. So we got m plus 8 and m plus 6. And now let's look through it. Find stuff on top and bottom that I can cancel. M plus 4, m plus 4. One on top, one on bottom. M minus 3, one on bottom, one on top. Now, the unfortunate thing is, this piece that we factored down here, there are no matching pieces with it, so we might have factored that for no reason, but we still had to check to see if it could cancel. So let's see, that's all that's on top is 7m squared. On bottom, we still have this. You can leave it like that, or you can multiply it back out how it would be from the beginning, because really there was no reason to factor that. But in the end, this is our simplified answer because there's nothing else that can cancel out. Alright, practice makes perfect, so let's see what else we can do. 7x over 24x cubed minus 64x squared times 9x minus 24 over 7x. See, right off the bat, you can see a 7x and 7x will cancel. So, I mean, that's a good way to start it. Now, the other pieces we do need to factor. So let's see. The 9x minus 24, if I factor out a 3, that leaves me with 3x minus 24 divided by 3 is an 8. Okay, we got rid of this top and this top, so really it's just one down here, one up here. 24x cubed minus 64x squared. Let's see, the number we can break out of that is an 8 and an x squared. 24 divided by 8 is a 3x. 64 divided by 8 is a 8. No more x's. And if I look at that, 3x minus 8, 3x minus 8, cancel, cancel. And now all that we're left with on top is 3 times 1, which is 3, and on bottom, 8x squared times 1, 8x squared. And the 3 and the 8x squared don't cancel anymore, so there we go. Final answer. All right. Looks like the last one for our notes. X squared plus 4x plus 3 over 9x plus 90 times x plus 10 over 10x plus 30. So again, you can't start canceling stuff until you've started factoring. So let's see what everything is built up of. So on top, I've got to use x factor. On the bottom here, that's a GCF, and nothing actually happens here. So I'm going to rewrite that one. I'm going to do the GCFs first because those are a little simpler. So the bottom right, I can take a 10 out of both, leaving me with x plus 3. Over here, I can take out a 9, leaving me with x plus 10. Now the x factor on the top, 3 and 4, that makes up a 3 and a 1. So that's an x plus 3, x plus 1. Oh, whoops. I'm sorry, down here, when I factor out the 10, that should be a 3, not a 30. So if I see things that match up, so x plus 10, x plus 10, x plus 3, x plus 3, and then kind of look around, am I left with anything else that can cancel? Let's see. what's left? Got this, the 9 and the 10. Nothing else happening, so let's bring it all together. X plus 1 on top and on bottom, 9 times the 10 makes a 90. So my final answer of x plus 1 over 90. So the thing to remember here, before you get started in canceling stuff, try to factor everything that you can. Factor everything you can. Once stuff is factored, now I can start canceling similar things. One has to be on the top, one has to be on the bottom. Doesn't matter which fraction it's on, as long as one is on the top and another's on the bottom.